Okay, so, so it says here, evaluate the given finite geometric series, use equation 12.3, which states that the sum of the first terms is given by this, and so let me just say, S sum n is A 1 minus r to the n, rho minus r. I didn't make much of a, I didn't stress this formula really at all. It came up when we came up with our geometric series formula. I didn't have the A in there, but that formula came up, and it just wants you to use this formula to figure out this finite sum instead. Remember, we had this formula, and then we said if r was less than 1 in absolute value, that r to the n would go to 0, right? And so we really took the limit as you went off to infinity. Here they're just asking you for the finite sum. And so let me just write this out. 12, 5 times 2 to the n minus 3. Okay. And so before you do too much writing here, let's remember this is A plus AR plus, right, AR to the n minus 1. That's the first n terms, right, of your series. And so when you have something that's starting at a different place, right, this is the sum from this k equals 1 to n of AR to the k minus 1, right? That's where this formula applies. So you got to just make sure this is in the right form. And so let's just work it out. So your r is going to be 2, right? Because you're multiplying by more powers of 2. But what's your a, and then what's your final value? So when you plug in 2, what do you get to here?
Negative 10.
Not negative 10.
5 over 2.
5 over 2, right? It'll be that negative exponent. So 5 halves. Does that make sense? And then when you plug in 3, you get just 5, right? Now when you plug in 4, well, 5, and let's just leave it as 2, 5 times 2, and then 5 times 2 squared. And what's the last term you're going to get to?
5 times 2, 11.
Yeah, so 5. So when you plug in 12, you get not 11, but 9, right? So 5 times 2 to the 9th. Does that make sense? So with this problem, we want to use this formula. A is what? 5 over 2, good. R is 2, and N is what? I think it should be 10, right? It should be whatever, right? You end up at 9, but your last term is n minus 1. So if you're at 9, your n was 10. So that's your n. Does that make sense?
So is that this n is not equal to this n?
Well, I mean, the n from the formula is the last n in your sum. And so they're using a different counter here. I mean, a better way to look at this would be to switch this to k's. Does that make sense? So the n in the formula isn't this thing that's changing, right? That's stuck into your sum. It's the last value you get to, or the n associated with that. And so now you should just be able to plug that in there. Is that okay?
Yeah.
Okay. Yeah.
How do you get 10? Should it be 11?
No, I think it should be 10, right? So this is your formula. K goes from 1 to n, right? Of this form. Let me see, what formula do they say? 12.3. Let me just make sure that I'm using the same one that they have. Because your n can be different things if you rewrite the formula slightly differently. What did I say? It was 12.3? Yeah. So that's the same one. So it's S sub n. It goes from 1 to n. Well, you add up to till you get to n minus 1. So whatever your last term you get to, the n is just 1 bigger than whatever that thing is. So it should be 10. Is that okay? final answer here should be S of 10 is right, A 1 minus R to the n, or I guess to the 10th, and then you just plug all that stuff in there. Okay. Other questions on this one?
So for this one, can I just, for n equals to 12 minus 2? Just use that, because it only get 10 too.
Right, I mean, you could, I guess you could think about it that way, because you're thinking whatever this is corresponding to your term 1, right? And then where do you get to? You'll get to, well, maybe we should be careful. I mean, it's corresponding to, so you have, right, you have 12, or you have 10 terms in there, I guess is the point, right? So, you gotta be careful because you're sort of running behind. Okay. Other questions? So, 27. Use the given information to determine if this series converges or if it's insufficient. And so let me just write this up. So you're trying to determine if the series from n equals 1 to infinity of a sub n converges or diverges, and then you're told this. Again, what does that notation mean? The an arrow 1/2? That's just the limit, right? That's just a different way to write the limit. And so what are we saying here? That the limit as n goes to infinity of a sub n is 1/2. So what do we know that about the series then? So what was the big theorem we had from the last section? Was that if the terms don't go to 0, then what? Then it diverges. And so the limit as n goes to infinity of a sub n is 1/2. If that's not 0, right, then this implies that your sum, I'll just drop the bounds there, diverges. Does that make sense? And as long as we have this up here, let's just remind ourselves, if the sum did go to 0, does that mean it converges?
No.
No, why not?
There is a
Harmonic.
harmonic series that can prove that it's not, is that still your convergence level?
Okay, good. That's what I was hoping for. Let's see. Okay. Let's squeeze in this last one here, 43. Okay, so it says convert the repeating decimal to a fraction, and you can do this in multiple ways. I'm going to do it in a different way than the book does, but I think it's okay. Okay, so they give you here 12.12 repeating, okay, and so there's, right, so this looks like that. Now let me just say one thing. This is equal to 12 plus, what is this? 12, the first part is 12 hundredths, right? And then the next 1, 2 is 12. Yeah, I'll just start writing this 100 squared, right? And then 12 over 100 cubed, and so on. Does that make sense? And so you have a geometric series here, right, with your A equal to 12 and your R equal to 1/100th. Does that make sense? And so you can follow the geometric, so use the geometric series with A12 and R 1/100th. I keep feeling like there's an issue with that. I think we might be right about 11, but I don't know. Because we do have 10 terms there, right? And so if we sum up from 1 to, I'll have to come back now. I think we did screw it up. I think you're right. I think it is 11. But I don't, something feels off to me. But anyways, back to this one. So if you do this and just use your geometric series formula, right, everything will work out okay. Let me give you an alternate way to do this. If you think x is 12.12121212 and so on, what is 100 times x? 12, 12.121212. So what if you subtract those from each other? Subtract x from this, you'll get 99x, right? Equals what? 1200, right? All the other 12s disappears, that makes sense? And so x is 1299. There's a real quick way to do it without the geometric series. The point of this section was to use the geometric series here. Yeah, let's think back to this. So if we start at 2, we definitely have an extra term showing up here. What am I screwing up? Oh, there's our problem, right? Our A is 5/2, so yeah, I screwed this up. So let's fix this. This is not the way to think of it. It's close. The end's 11, but let's make sure we see why and why I screwed up. Sorry about that. Right, your A was 5/2, right? And so you should keep your A in the problem and then make it 2, and then it's 5/2 over 2 squared. Sorry about that. 5/2 over 2 cubed. 5/2 over 2 to the, well, now to the 1 more than we had, right? What did we say? It was 9, so it'll be 2 to the 10. And so your n minus 1 is 10, so n is 11. That looks perfect. Nice. Does that make sense? So we screwed up before because your A is really, your A has to stay that 5/2. And so when I pulled off the power of 2, I grabbed the wrong power because I had pulled the 2 out of the denominator. So you only get that if you have sort of repeated issues. But that's why I'd suggest you always write it in this form first, pull your A off, and then leave, you should always write it should be A times R, and so leave your A in the right form, plus A times R squared and so on. Thank you. I got a little lazy there. Does that make sense? All right, so let's see, 45. Says, for the given series, write an unsimplified expression for S4. Draw the result from part A to find the general form of S sub n, the partial sums, and then use the formula from part B to determine if the series converges or diverges and find its sum. So I know you're asking about C, but let's just go through the whole thing. We have up here, so it's 45. The sum is from 1 to infinity, and 3 over n plus 1 minus 3 over n. And so now we want to add this up and see what we end up with. So what's S sub 1?
3 over 2 minus 3.
3/2 minus 3. What's S sub 2? Well, it's 3/2 minus 3 plus what?
3 over 3
plus 3 over 3
minus 3 equals 2.
minus 3 halves, good. So, we get that, right? What's 3 sub 3? So, again, you can start trimming these off if you want. I'll just write this out again. Same thing, right? The 3 halves cancels. What's the next term that gets added in here?
3/4 minus 1.
3/4 minus 1 minus 3 halves, or 3/3, right? And so the 1s cancel, right? So you end up with that. And then finally, S sub 4. Again, if you want to just, maybe I'll start doing that now. Right, so all the other stuff that we have canceling here is going to cancel. So we're, from S3, we're left with -3 plus 3/4, right? And then what do we get for our final term? Plus
3 over 5.
3, or I guess our next two terms, 3 over 5 minus 3 over 4. Does that make sense? And so those cancel again. Okay. And you can draw a few more out if you don't see the pattern right now. But what does it look like your S sub n is? Well, the -3 isn't going anywhere, right? That's going to stick around. And then it looks like you always have this one term, right? It was 3 halves, 3/3, 3/4, 3/5. And so for the n, it looks like it's just 3 over a rising n, and it's 1 ahead of your S sub whatever, right? So you come up with that. So there's the general form. So I guess this is really, right, part A, part B here, right? And then part C is to determine if the series converges or diverges by taking the limit. And again, what happens here? 3 over n plus 1 goes to 0. So the whole thing should go to -3. And so that's the value, and in particular, right, the series. 3 over n plus 1 minus 0 over n converges. Is that okay?
Yeah.
All right. Okay, I'll stop there for 2. Any 12-3 homework that we want to go over? We gotten there yet?
Nah, I'll probably have some tomorrow though.
Okay, that's fine. Just move on that. All right, well, we'll move into 12-4 here.